Hi children, we are continuing with our lessons and we are continuing with the lessons on sets. In the last lesson we did some introduction work on sets and we found out how to identify a set and then continue with that. Today we are continuing again and here we must know there are two things that we should know: finite sets and infinite sets. Two things we must know first. What are finite sets? Finite sets means where the elements are sure, where it is definite. For example, if we say multiples of 3 between 0 and 20, the example given in the book, multiples of 3 between 0 and 20. So definitely we can tell multiples of 3 between 0 and 20 as 3, 6, 9, 12, 15, 18, that's all. So this is finite. We doesn't go beyond that. Definitely we can say these are the multiples of 3 between 0 and 20. We can't get any other number. 4 is not there. 4 is not a multiple. So this is a finite set. So what are infinite sets? Infinite sets means it goes on and on and on. We can't identify. It doesn't stop. For example, multiples of 5. Multiples of 5 means we don't know how many it is. 5, 10, 15, it goes on like that. So this is infinite. So we have infinite and finite. Finite and infinite. For example, the good children maths, we don't know, it's infinite. Polygons is going on and on. So we don't know that was definite in that. So it is infinite. So these are the finite and infinite sets. Look at the next thing. We must know what equal sets are. For example, equal sets. What are equal sets? Now, for example, we write like this: M is equal to 2, 3, 5, 7. 2, 3, 5, 7. We'll say X is equal to prime numbers less than 8. Prime number less than 8. So, so we can write the elements as X as prime number less than 8 will be 2, 3, 5, 7. So, M is equal to 2, 3, 5, 7, that is what is given, and X is given to prime number less than 8. Prime number less than 8, when you write the elements, it becomes 2, 3, 5, 7. So, we say M is equal to X because the elements are equal. When the elements are equal, we say that the sets are equal. Look at the next one. Equivalent sets. Look at this set. P is equal to A, E, I, O, U. Q is equal to, we'll say 5, 4, 3, 2, 1. So these are two sets. P is equal to A, E, I, O, U and Q is equal to 5, 4, 3, 2, 1. Now here the elements are, how many elements are here? NP is equal to 5. Here NQ is equal to 5. So here the elements are equal in both P and P. So we say P is equivalent, we put the line like this, equivalent to Q. This is the sign for equivalent. So when two elements have same number of elements, when two sets have same number of elements, we say that those two sets are equivalent. So this is a sign for equivalent. Now look at exercise number 22.1, sorry. Look at the exercise. First one. From the sets given below, select and write the finite and the infinite sets. For example, first one, A. multiples of 5 between 0 and 50. A. Multiples of 5 between 0 and 50, we can immediately say, write down the elements, we can say A is equal to 5, 10, 15, 20, 25, 30, 35, 40, 45. So, A multiples of 5 between 0 and 50. So, these are the elements of A. Definitely these are the elements. We can't, there are no other elements. So, we say these are finite sets. So, we will call this finite, F. Integers, B. Integers. Integers are whole numbers. Whole numbers, there is no limit. It goes on and on. So we say we can't. So we can't say it is finite. It is infinite. We put I for the infinite. Second one. Third one. Numbers that can be written using only the digits 0 and 1. See, number with 0 and 1. 0 and 1 we can write quite a lot of numbers. That is, you can put 10, 100, 1000 and so on. So that's also indefinite. Infinite numbers. The digits of the number 25265. D. 25265. Digits of the number 25265. Digits of this number. So what are the digits of the number? So digits of the number will be 2, 5 and 6. So definitely these are the digits. So it is a finite set. Then look at the next one. Positive integers which are not prime. Positive integers which are not prime. So positive integers which are not prime is E. Not prime. So you can say 4, starting with 4, 6, 8, 10, which are not prime, 9. So these are all, and it's continuing. Positive integers which are not prime. Now 4 is not a prime number and positive. 6 is not a prime number, positive. 8, 9, 10, 12, 14, it's going on limitless. So these are all positive integers which are not prime. So it is also infinite. So out of that letters given there, first one A is finite because we have numbers are the elements are limited. B is infinite integers, we don't know how much goes. C is also integer, the numbers go 10, 100, 1000 and go on infinite. F is finite because out of the numbers 25,265, the digits are 2, 5 and 6. And I is also infinite because the not prime numbers are 4, 6, 8, 9, 10. Look at the next question. Question number 2. Write each of the following sets in terms of their elements and then write all the pairs of equal and all pairs of equivalent sets. So first of all, you have to write the sets in terms of the elements. Write each of the following sets in terms of its elements. Now P is equal to positive multiples of between 3 and 10. Positive multiple of 3 below 10. So positive multiple of below 10 will be 3, 6, 9. P. Q is equal to letters of the word net. Letters of the word net will be N, E, T. R will be odd numbers between 0 and 10. Odd numbers. 1, 3, 5, 7, 9. Odd numbers between 0 and 10. R. S is digits of the number 3693. Digits of the number 3693 will be 3, 6 and 9. 3, 6, 9. T. Vowels of the English alphabet. So that will be A, E, I, O, U. Then U is equal to letters of the word 10. That will be T, T, E, N. Letters of the word 10. So these are the elements of the one. First one, prime P is equal to positive multiples of between 3 and 10. Positive multiples will be 3, 6 and 10. Q is letter of the word net, N-E-T. Odd number between 0 and 10, 1, 3, 5, 7, 9. Digits of the number 3, 6, 9, 3. 3, 6 and 9. Vowels of the English alphabet A, I, O, U, and V is letters of the word 10, T, N. Now write each of the following elements and write the pairs of equal sets and all pairs of equivalent sets. So equal sets will be in this one if we take equal sets. What are the equal sets in this one? So equal sets will be P and S. P and S, 3, 6, 9, because the elements are equal. So P is equal to S. P and S. What is the other equal set you get here? Q and U. Q, N-E-T, U is also T-E-N. Elements are equal. So Q and U. Q equals U. These are the equal sets. Then equivalent sets. Equivalent sets, we have quite lost. That is only the element must be equal. First of all, we have P is equivalent to Q. P is equal to, because element 3 here. Then we have P equal to U. P equivalent to U. Why? 3, 3. Then we have Q equivalent to S. Q equivalent to S. Q equivalent to S. 3. Element 3. Then we have Q equivalent to U. Q equivalent to U. Q equivalent to U. Then we have R equivalent to T. R equivalent to T. How many? 5 elements? 5 elements. So R equivalent to T, and we have S equivalent to U. S equivalent to U. S equivalent to U. 3, 6, 9. So these are the elements for the, these are the answers for the question number 3. Sorry, question number 2. Look at the third question. Write 3 examples of finite sets. So what are the examples you can give out finite sets? You can say trees in the garden. The number of large trees in the garden, you can say, you can definitely say what are the trees. Then boys who got more than 50 marks in maths in the class. Boys who got more than 50 marks in the class, you can say definitely how many you got. And the colors of the rainbow, definitely finite sets. Violet, indigo, blue, green, yellow, and there are 7 colors. The colors of those are finite sets. Then fourth question is write 3 examples of infinite sets. What are the infinite sets you can get? You can say stars in the sky, infinite, nobody can count. It's there. Then numbers, factors of 3. Factors of 3, we don't know. Then we can say multiples of 7, multiples of 7, infinite. Those are infinite sets. Then look at the fifth one. Write 3 sets which are equivalent to set 2 and 3. Equivalent to 2 and 3. Equivalent means they must have the same number of elements. For example, we can say x is equal to squares, rectangles. Equivalent. So we can say y is equal to p, q. Equivalent set. So either we can say is equal to mango and apple. They must have only two elements here, two elements. So all these sets are equal. So that's all for today, children. I hope you have understood this, and if you understood, please subscribe.